transverse wave. This is the positive peak called crust and this is the negative peak called trough. Otherwise, there is a mistake in the previous thing such that the positive peak is called a crust and the negative peak is called a trough. That's the main mistake regarding the previous section. The thing is that it is not the positive peak called a trough. The positive peak is called a crust and the negative peak is called a trough. That's the mistake regarding in the previous section. So here the positive peak is called a crust and the negative peak is called a trough. Okay, the positive peak is crust and the negative peak is called a trough. Here the distance between two consecutive the distance between two consecutive crust or the distance between two consecutive trough is called wavelength lambda. The distance between two consecutive crust or the distance between two consecutive trough is called wavelength lambda. So wavelength lambda. Wavelength lambda. So what is wavelength? The distance between two consecutive distance between two consecutive crust or distance between two consecutive trough is called lambda, which is called the wavelength. What is the unit of wavelength? Unit of wavelength is meter. Why the unit of wavelength is meter? Because it is the distance between two consecutive crust or distance between two consecutive troughs. Since it is a distance, the unit of distance is meter, therefore the unit of wavelength is also meter. So that's all about the wavelength. Then we want to find the amplitude. What is meant by amplitude? Amplitude. So the maximum displacement of the wave is called amplitude. Maximum displacement of the wave is called amplitude. Maximum displacement of the wave is called amplitude. This is the amplitude, maximum displacement of the wave. This one is the maximum displacement in the wave and this is called amplitude A, which is denoted by capital letter A. The unit is same as that of the wavelength because the reason is that the maximum displacement of the wave. Maximum displacement means the unit of displacement is meter, therefore the unit of amplitude is also meter. So two quantities are our amplitude and wavelength. Third one is frequency. Frequency. Frequency is denoted by the letter nu, or otherwise we can use the letter small letter f. Whatever you like, we can use. So frequency nu, number of cycles or vibrations or oscillations in 1 second is called frequency. So number of cycles or vibrations or oscillations in 1 second. That means in 1 second there will be 3 oscillations are completed. Then the frequency is 3. In 1 second there will be 5 cycles are completed. Then the frequency is 5. That means number of cycles or vibrations or oscillations. It depends upon the circumstances. Here in the case it will be cycles. Number of cycles in 1 second. For a simple pendulum it will be oscillations. For a stretched band it will be vibration. That changes with respect to the circumstances. So number of cycles or vibrations or oscillations in 1 second is called frequency, which is denoted by nu. The unit of frequency is hertz. HERTZ, which is denoted by Hz. The unit of frequency is hertz. So here three quantities are completed: amplitude, wavelength, and frequency. Number of oscillations or vibrations or cycles in 1 second is called frequency, and the unit of frequency is hertz. And simply the speed of the wave is called its velocity itself. The speed of the wave or the velocity of the wave, as we know that the speed of the wave traveling in a medium is considered as its velocity also. Now we want to check what is meant by time period. What is meant by time period? Time period. Time period is the time taken to complete one oscillation or vibration or cycle is called time period, which is denoted by capital letter T. So the time taken to complete one oscillation, that means if 3 seconds is to complete one oscillation, or if 4 seconds is to complete one oscillation, or if 5 seconds is to complete one oscillation. In the first case the time period is 3, the second case the time period is 4, and in the third case the time period is 5. Whatever time is taken to complete one oscillation or one vibration or one cycle, that will be considered as time period. So simply the time period is the time taken. So we can say that the unit of time period is second. The unit of time period is second because it is the time taken. So now we want to check the relationship between all these quantities. The first relation is relation between frequency and time period. The relation between frequency and a time period, that is frequency is the reciprocal of time period. Frequency is the reciprocal of time period. That means frequency means nu is equal to 1 by t. This is the relation. Frequency is the reciprocal of time period, or otherwise we can say that time period is the reciprocal of frequency. T is equal to 1 by nu, or nu is equal to 1 by t, where nu is the frequency and t is the time period. The next relation between frequency, velocity and wavelength. The relation between frequency, velocity and wavelength, that is the relation is nu is equal to v by lambda. This is the relation. That is nu is the frequency, v is the velocity and lambda is the wavelength. If all the three quantities are given, if the frequency is given by nu, velocity is given by v and wavelength is given by lambda, then the relation is nu is equal to v by lambda. So this is the relationship between frequency, velocity and wavelength. Already we discussed about the characteristics of wave. What are the characteristics of wave? We discussed amplitude, wavelength, frequency, time period and velocity. And there is some relationship between velocity, frequency and wavelength. What is the relationship between frequency, velocity and wavelength? Nu is equal to v by lambda, where nu is the frequency, v is the velocity and lambda is the wavelength. And also there is a relationship between frequency and time period. What is the relationship between frequency and time period? Frequency and time period are always reciprocal. That means frequency is the reciprocal of time period. That is nu is equal to 1 by t, or otherwise we can say that t is equal to 1 by t. Here we want to discuss about some characteristics of sound, particularly characteristics of, not the wave, particularly we want to discuss about the characteristics of sound. What are the characteristics? We already written about intensity, loudness, pitch, tone, quality, and note. These are the characteristics of sound we want to discuss. First of all, intensity. What is mean by intensity? The amount of sound energy transported per second per unit area of cross section normal to the direction of propagation is called intensity of sound. The amount of sound energy transported per second per unit area normal to the direction of propagation is called intensity